11.7. So factoring this, two numbers that multiply to be 36 and add to be 12. So that's going to be x plus 6 and x plus 6. If you wanted the roots, it's just x equals negative 6. How can a quadratic hit the x-axis at negative 6 twice? What is that going to look like? Well, if I had, let's say I had a quadratic that looked like this, it has two positive roots. And if I move that up, still has two positive roots, still has two positive roots, and now it has a single root at 6. So anytime a root occurs twice, that root will be represented as a bounce on that axis. So I could graph this as x plus 6 squared, and that's just the graph x squared. Oh, should be negative 6. Let's change these to minuses. That is the graph of x squared that has shifted to the right 6 units. So this is what x squared looks like. And if I shift it to the right 6 units, now I have a bounce. What if I had x minus 6 to the third? Well, that's going to look like a saddle. That is a triple root. And then a root, if you had 4 copies of it, it would be a bounce. If you had 5 copies of it, it would be a saddle. Okay. Here we factor v minus 4 and v minus 2. So v equals 4 and 2. Okay. V squared minus 49. I'm going to rewrite this as v squared plus 0v minus 49. Are there factors of negative 49 that add to be 0? 7 and negative 7. So this is one of those special cases we call a difference, a difference of perfect squares. And that will factor into v minus 7 and v plus 7. So what are the roots there? 4 and negative 2. Oh, I got to get rid of this one. That one shouldn't be there. All right. So 25v squared and 36. Multiply those together, which is going to be a big number. 25 times 36 is 900. And I want two numbers that multiply to be 60. So 900 divided by 24, that didn't work. 900 divided by 25. 25 and 36 don't add up to 60. 900 divided by 26 is going to work. 27. Nope. 900 divided by 28. Nope. 900 divided by 29 is prime, so I'm going to skip to 30. There it is. So 30v so 30v and 30v. What can I pull out of the top row? A 5 and a v. What can I pull out of the first column? A 5 and a v. And I get 5v plus 6 and 5v plus 6. So those are my two factors. If it wanted me to find the roots, I would subtract 6 and divide by 5, and v would be negative 6/5. Okay. This is just a difference of perfect squares. It's going to be 7v minus 2 and 7v plus 2. This is a difference of perfect squares. 2z minus 5x and 2z plus 5x. Here, I want to pull out 4 is the biggest I can pull out. So 4x to the third. And I'm left with 3x squared minus maybe 56 divided by 4. My calculator died. Is 14. 14x plus 8. So this one I have to use the box. I stick in the 3x squared and the 8, multiply those together, 24x squared. Factors of 24 that add to be 14 would be negative 2x and negative 12x. Pull out an x, and I get 3x minus 2 and x minus 4. So the factors are 4x to the third, 3x minus 2, and x minus 4. If it wanted me to find the roots, this root would be 4, this root would be 2/3, and this root is going to be 0. So this graph would cross the x-axis at 4, at 2/3, and then it would have a saddle at 0. So it's going to look something like this. So 0, 2/3, and 4. Okay, this does not appear to factor, but if we pull out the greatest common factor, which is going to be 2, pull out a 2y. If I yank out a 2y, I get 36y squared minus 25. And now that is a difference of perfect squares. So 2y times 6y minus 5 and 6y plus 5. Okay. That's it. Get to work.